Our 2.4 notes is over transformation of parent functions. Remember, tomorrow you have a quiz over parent functions. Maybe at the end of this notes, I will show you a few links that you can go to study your parent functions. Let's start with number 1 and number 2. Note that A is inside the parenthesis. For these two, this will give you your horizontal shift. Now, although they're horizontal, two things can happen. It can be left A whenever it's positive, but when it's negative, that'll be right A unit. Now, for 3 and 4, this time the value is on the outside. For both of them, those will be your vertical. When I say horizontal and vertical, I'm talking about vertical and horizontal shift. Now, the positive one will be when it goes up a unit, compared to the negative one is when it goes down a unit. On number 5 and 6, now we have stretch and compression, but they're not the same. When it's on the outside of the function, such as number 5, you will have a vertical stretch or compression. It will be a stretch when the absolute value of A is greater than 1, and it will be the compression when the absolute value of A is greater. This is less than 1 for verticals. A stretch will be bigger than 1. Compression, that is when it's less than 1. When the A is inside the parenthesis, this one is instead your horizontal. It can be a stretch or a compression again. It will be a horizontal stretch if the absolute value of A is less than 1. Note that it's flipping, it's different than the vertical stretch. And it will be a compression if the absolute value of A is greater than 1. In other words, it flipped from vertical to horizontal, stretch and compression. The negative on the outside is just a vertical reflection. Another way to call vertical reflection, you can say reflection over the x-axis. Compared to this, where is the horizontal? The vertical reflection is outside, the horizontal reflection is inside. So this one is horizontal reflection, and horizontal reflection is a reflection over the y-axis. Alright, the absolute value function, on the other hand, will flip all the function above. Let's say, for example, I have a function that looks like this, and I'm giving you, let's say, a cubic root function that looks like this. The absolute value of a cubic root function, instead of looking like this, is going to flip all negative to the positive, and it will look like this instead, like the red one. In other words, whenever you have the absolute value, all range is taken to the positive side. So negative y's become positive, and positive y's stay positive or stay the same. Alright, for f of absolute value of x, this is slightly different. Here I would say all domain is taken absolute value. Since all domain is taking absolute values, negative x's points disappear. Negative x points disappear and mimic positive x points. Alright, let's go ahead and go on to the next page and see what we get. Now we have graphs, and our goal is to graph the transformation. First thing you need to know is on problem number one, the fact that I have the half inside the parenthesis, I know I have a horizontal stretch. Now, the negative in front is a vertical reflection, and the plus 2 means it went up 2. Let's try to graph it. In order for me to graph it, I will pick specific points, those points that I'm highlighting. The first thing is point -3. Apparently f of -3 is 0. In order for me to get -3 inside the parenthesis, I will shift that to -6, meaning somewhere here, because -6 over 2 will give me that -3. Well, f of -6, half of -6 is 3, f of -3 will be 0. With a negative, that's still 0. So at this point, I will climb to 2. Let me plug in a different point. I will plug in this point now, which is -1. In order for me to get -1 inside the parenthesis, I need to plug in -2 here. So I'll be looking at -2. Now, once I get f of -1 here, it's normally -3. So I have -3 plus 2. And if you perform -3 plus f of -3, now with a negative, return to +3 plus 2 will give me 5. The next point is the point 0. F of 0 normally is 2. In order for me to put 0 here, well, 0 remains 0. So if I plug in 0 here, I still get 0. And instead of having 2, I'll be f of 0 is 0. F of 0 is 2. -2 plus 2 is 0. So far, I know that my equation will look like this. Like this. Now I'm at this point. F of 1 is 0. To get 1 here, I need to plug in 2. And if I plug in 2 here, I'm right here. And f of 2 will therefore be 0. So I will rise up to 2, meaning here. And from here, I will just graph a straight line. The last portion is 3. F of 3 also is 0. So in order for me to get 3 here, I need to plug in 6. And if I plug in 6, the whole thing turns into 0, and I jump right here. And note that this is like a quadratic, a semicircle. If it goes up like this for a regular one with a negative in front, it will make a curve like this. Now you can always plug in 2 to check where it goes, but I'm positive it will be here. Let's go ahead and look at one more. Or you can do this one by yourself. It's the easiest thing ever, because all you have to do is find the absolute value of it, meaning it will move to the left 2. And after left 2, you use the absolute value of y's, meaning flip everything up and down. Left 2, I will do it in blue. If you move everything to the left 2, that means this point turns here. This point will be here. This one will be here. This one, oh, I'm doing right. Sorry. Doing left, you're moving everything to the opposite side, meaning here. Move everything to the left, not to the right, as I was doing. Here. This point we move 2 units. Right there. It's 2 units, not 1. I made 2 mistakes on this problem so far. But let's keep going. If I keep going, I'll move also this point here. This point we move right here. And from here, you will connect the dots. This point we move right here. And it will still give me a semicircle here. Well, here's my transformation. The first transformation, all I did was left 2. The absolute value will flip everything that is negative to the positive. In other words, this negative side that I'm making green now will flip, and it will give me the red one that I'm graphing now. And that's it. All right, let's look at the next one. Number 3 and number 4. On number 3 and 4, I will go ahead and graph it, and you do the same, and you just check if you got the correct answer. Now that you had a minute to do it yourself, let's go ahead and do it together. First thing is, looking at this, I know that with the negative inside, I have a horizontal reflection. Beside the horizontal reflection, I also have, with the 2 in front, I have a vertical stretch. And the 1 on the outside is going to go down 1. Let's go ahead and go step by step. It might get a little messy. Once again, the points that we worry about are these points. The first thing I will do is, a -3, apparently f of -3 is supposed to be 0. In order for me to get -3 in here, I need to plug in 3. So if I plug in 3 here, I get 0 for this function. 2 times 0 is 0, minus 1. So at 3, I'm 1 unit down. It will give me this blue point. I'll keep going step by step. The one following it is -1. F of -1 apparently is -3. So to get -1 here, I need to plug in 1. And if I plug in 1, I get 3 in this function. 2 times 3 will be 6, minus 1 will give me 2 times -3, -6 minus 1 will give me -7. So at 1, I'm at -7. I'll do the same thing for the point 0. F of 0 apparently is 2. So if you plug in 0 to this equation, you will get to 2. Well, 0 here will still give me 0. That will be 2 here. 2 times 2 is 4, minus 1 is 3. So at 0, I'm at 3, meaning somewhere here. Next point is the point, by the way, if you're cautious, you might as well go ahead and connect this point to this point to this point. The next point is the point 1. In order for me to plug in 1 here, I need -1 to turn into 1. And f of 1 is 0. So if I plug in 1 here, I get 0 total. And if I plug in -1, I get 0. 2 times 0 is 0, minus 1 is -1. So at -1, I'm at -1, meaning this point. The last point, instead of 1, I can also plug in 2 to see how high it's going to get. So I'll go ahead and plug in 2. Since f of 2 is 1, it means that I'm plugging -2 in here. And if I plug in -2, I get 1. 2 times 1 is 2, minus 1 is 1. So at -2, I'm at 1, meaning here. The last point is the point 3. In order for me to get 3 here, I'll plug in -3. And f of 3 is 0. So this whole thing will be 0, and I get back to -1. Of course, I will connect these two, and I will make the curve here. And it's a positive because it was a plus. One last one. For this last one, the first thing I have is the absolute value of x. And I can say, well, with the -2, it went to the right. Right 2. It will go also up 1. And we got an absolute value of x. So let's go step by step. Once again, I'll focus on these red points, because with those points, I can come up with the graph. The first point is -3. So if I plug in f of -3 is supposed to be 0. But in order for me to get -3 here, well, guess what? If you plug in -3 in this one, there's no way you're going to get, it's going to turn into 3. And you will have 3 minus 2, which is 1. So it's going to give you f of 1. So to find the new f of -3, where would this one transform? Go ahead and plug in if you want, and let's see what you get. So let's start with the first one. I plug in -3. -3 will give me 3. 3 minus 2 is 1. Well, what is f of 1? F of 1 is 0. plus 1 will give me 1. So at negative 3, I'll move to 1. Now I'm going to plug in this point, which is the point negative 1, negative 2. If I plug in negative 1 here, I have absolute value of negative 1, which is 1 minus 2 will give me negative 1. Well, f of negative 1 is negative 3. Negative 3 plus 1 is 2. Negative 3 plus 1 is negative 2. So I'll move it up somewhere here. So far I got this line. I'll keep going. This time I'll put 0. F of 0 is 2. If I plug in 0, I get to negative 2. Well, it's not quite a point that I can manipulate. 0, but that's okay. If I put 0, I get f of negative 2. Well, f of negative 2 seems to be at 1.5. 1 plus 5 plus 1 is about 2.5. So 0 will be about 2.5. Now, somewhere here. Now, let's go ahead. F of negative 2. F of negative 2 is negative 1.5, so it's actually lower. Negative 2 is somewhere here at negative 1.5. If you add 1, you're at negative 0.5. So you're going to be somewhere in between here. That was my fault. So I have this much. Now I'll plug in 1. If I plug in 1, I get 1 minus 2 is negative 1. F of negative 1. F of negative 1 was negative 3. Negative 3 plus 1 will be at negative 2. So it's taking you back right here. Well, I'll plug in 2 now. If I plug in 2, I get f of 0. Well, f of 0 is 2 plus 1, I'm at 3. So I'm going all the way to here. And the last point, note that it's going to make a curve at that level. If I plug in 1 or 3, I'll get 3 minus 2, which is 1. F of 1 was 0. So this whole thing is 0. So at 3, I should go back to 1. So it will go like this. After making this shape, it will go all the way up here. It will do this. Now, it will make also a curve. How do we know how far we're going to make? So plugging, my goal is to find where it's going to do this little curve. Let's look at f of 4. If I plug in 4, that will be 4 minus 2 is 2. F of 2 was 1. 1 plus 1 is 2. I plug in 5 now. 5 minus 2 will be 3. F of 3 was 0. Plus 1, 1. And here's your last curve. There are a few more things I want to show you. I want you to go on Google. Once you reach Google, the first thing I want you to do is on the Google, go ahead and type parent function graph. Once you hit parent function graph, go ahead and select the first link where it says She Loves Math. Under She Loves Math, I want you to review this parent function, the linear, the cubic, including your domain. I don't care about the behavior, so make sure you look at the domain range of all these functions. Very important. It's also on the front or on the cover of your book. But this is not all. Besides this, I also want you to review your trig function. Once again, you know you have a quiz on this, so take the time to review. I also find a different website. If you just type parent functions on Google, just type in parent function on Google, I found something else. I think it's the first link. No, not the first link. Maybe it was the second link. And you go ahead and find different ways or different graphs you can see up there. If in case it's not important for you, just base yourself on what you see on the cover of your book and you should be fine for the quiz. You will only have 5 to 10 minutes max to complete this.